This is Introduction to Molecular Formula and Empirical Formula. We will talk about what are they, what are the differences between them, and how do you write an empirical formula when given a molecular formula. Let us take an example to understand what is molecular formula and empirical formula. We take ethene. This is ethene. Molecular formula can be defined as how many atoms of each element are in a compound. Okay, molecular formula is actually telling about how many types of elements in a compound and what are the actual number of that atoms in a molecule. It is actually telling two things: types of atoms or elements and the number of each atom. Okay, here in the case of ethene, there are two elements, carbon and hydrogen. So there are two types of elements, carbon and hydrogen. Now count the number of these atoms. There are two carbon atoms and 1, 2, 3, 4 hydrogen atoms. Okay, C2H4, it is the molecular formula of ethene. It is actually telling the number of atoms of each element. So it is molecular formula. Now if we want to derive empirical formula of ethene, so what would we do? In ethene, there are 2 carbon and 4 hydrogen in molecular formula. So first we understand what is empirical formula. Empirical formula is tells us the simplest whole number ratio of each element. Okay. Empirical formula. Empirical formula is actually telling the simplest number of atoms, simplest number of ratio of each atom in a molecule. So let us calculate the empirical formula of ethene. In ethene, there are two elements, carbon and hydrogen. There are two carbon atoms and four hydrogen atoms actually in the ethene molecule. Now we will take the simplest ratio of carbon to hydrogen. We will cut these numbers by the one largest number. So the largest number which will cut 2 and 4 is 2. 2 ones are 2 and 2 twos are 4. So in ethene molecule, in the empirical formula, there is 1:2 of carbon and hydrogen. So empirical formula of ethene is C, we will not write 1, okay, and H2. So it is the empirical formula of ethene. CH2 is empirical formula of ethene molecule. Okay. Now we will take another example to understand much about molecular formula and empirical formula. We take another molecule. This is benzene. Okay. Now there are two types of elements, carbon and hydrogen in the benzene. Carbon and hydrogen. These are the two elements which are present in benzene. Now calculate their numbers of atoms. 1, 2, 3, 4, 5, 6. There are 6 carbon atoms. 1, 2, 3, 4, 5 and 6 and 6 hydrogen atoms. So this formula is telling the types of elements in a molecule as well as the actual number of atoms of carbon and hydrogen. These are 6 and 6. There are 6 carbon atoms and 6 hydrogen atom in the molecule of benzene. So it is the molecular formula of benzene. Now we derive the empirical formula of benzene. The molecular formula of benzene is C6H6. Okay. So there are two types of elements, carbon and hydrogen. There are 6 carbon as well as 6 hydrogen atoms in benzene molecule. Now take its simple ratio by cutting with largest number. So 6 ones are 6 and 6 ones are 6. So in the case of benzene, there are the simplest ratio is 1:1. For each carbon atom, one hydrogen atom is present. It means for each single carbon atom, single hydrogen atom is present. So we can write the empirical formula of benzene as C. We will not write 1 and H. CH is empirical formula of benzene. Okay. Now it is important to discuss here that there are certain compounds which contain more than 2 types of elements. Okay. There are compounds which contain more than 2 types of elements. In the previous 2 examples in benzene and ethene, there were just 2 elements, carbon and hydrogen. Now we will take example of a compound containing more than 2 types of elements. For example, I take glucose. Okay. Glucose is C6H12O6. Now look at this. This is C6H12O6 is telling us there are 3 types of elements: carbon, hydrogen and oxygen. There are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. 6, 12 and 6 is not the simplest ratio, so it's mean this is the molecular formula of glucose. C6H12O6 is molecular formula. Okay. Now how will we derive empirical formula? There are 3 types of elements: carbon, hydrogen and oxygen. There are 6 carbon, 12 hydrogen and 6 oxygen. Now cut these number with the largest number. This can be cut by 6. 6 ones are 6, 6 twos are 12, 6 ones are 6. So the ratio of carbon, hydrogen and oxygen is 1:2:1. So we can write the empirical formula of glucose as C. We will not mention 1. H2O is 1. So we will not mention it. So CH2 is empirical formula of glucose. Okay. Here is one more thing to mention is that if the ratio of atoms in the molecular formula can't be simplified anymore, then the empirical formula is the same as the molecular formula. Now take an example to understand this point. For example, if there is a molecule with molecular formula C12H22O11. Okay, this is the empirical formula, this is the molecular formula of sucrose. Molecular formula of sucrose. Okay, C12H22O11 is molecular formula of sucrose. It is telling the types of elements. There are three types of elements: carbon, hydrogen and oxygen in sucrose, and also telling the actual number of atoms of each element present in the molecule. There are 12 carbon atoms, 22 hydrogen atoms and 11 oxygen atoms. Now if we want to derive its empirical formula, there are carbon, hydrogen and oxygen in sucrose. 12 carbon atoms, 22 hydrogen atoms and 11 oxygen atoms. Now note it here, 12, 22 and 11 cannot be cut by a single largest number. Okay, it means 12, 22, 11 is already a simplest whole number ratio of carbon, hydrogen and oxygen in sucrose molecule. So its empirical formula will be same as its molecular formula. What will be the empirical formula of sucrose? C12H22O11. So C12H22O11 is empirical formula of sucrose. So note here that the empirical and molecular formula of sucrose is same for sucrose because it is already in the simplified whole number ratio. Okay. We can take some more examples of the molecules which have same molecular formula and empirical formula. For example, NH3, ammonia. Its empirical formula is also NH3. CH4, methane. It is also simplest whole number ratio in molecular formula as well as empirical formula. So the molecular formula and empirical formula of methane is same. There are many more other examples which have the same condition in which the empirical formula and molecular formula are same. So don't get confused. Most of the teachers and textbook love to give you molecular formula that you can't reduce anymore and then ask you what the empirical formula is this. So never get confused and just say that the empirical formula is the same as the molecular formula. Okay. Now finally I want to mention that many different compounds can all have the same empirical formula. For example, C2H4, ethene. This is the molecular formula. Okay. So what would be its empirical formula? CH2. Okay. C3H6. It is propene. So the simplest whole number ratio in this case is also 1:2. 3 ones are 3, 3 twos are 6. So its empirical formula will be CH2. Same as of ethene, CH2. C4H8. So it is butene. Okay. Now if I derive its empirical formula, 4 ones are 4, 4 twos are 8. So its empirical formula will also be CH2. Okay. There are many more such molecules which have the same empirical formula. They have the different molecular formula, but their empirical formula is same, like ethene, propene, butene. Okay, all have the empirical formula CH2. Now I conclude the whole lecture. So the molecular formula is how many atoms of each element are in a compound. And the empirical formula is the simplest or the more reduced ratio of the atoms in a compound. The second point is to remember, if the ratio of the atoms in the molecular formula can't be simplified anymore, the empirical formula is the same as the molecular formula. For example, C12H22O11 is sucrose. Its empirical formula is also C12H22O11. NH3 ammonia, its empirical formula is also NH3. CH4 methane, its empirical formula is also CH4. Okay, and the last thing we have discussed in the lecture, different compounds could have same empirical formula. For example, C2H4, C3H6, C4H8. All these three compounds will have same empirical formula CH2. So remember that there are many compounds which can have same empirical formula. This is all about the molecular formula and empirical formula. In the next video, we will learn how can we derive molecular formula from empirical formula. Thank you.